Welcome guys, Sizosakhe here, Sizosakhe Academy, and this is the global classroom. We're still on trigonometry, guys. I thought I should put all this in proper perspective, so to speak. We've dealt with angles, where angles came from, how angles are put here from 0 degrees right round to 360 degrees. We also dealt with the radians. We explained why we have to have radians. Radians are an alternative for degrees. We use radians as well. And check that video where we do radians. We explain how radians come about. 30 degrees being equal to pi over 6. 45 pi over 4, pi over 3 is 60 degrees, pi over 2 is 90 degrees. Right round, we go right round, explaining it until we get to 2t. Sorry, 2 pi, not 2t. 2 pi, which is equal to 360 degrees. The video will show you how we get to 2 pi, how we get to pi, and the other radians, right? We also have ratios, special angles with ratios. So we did ratios for 0 degrees, which is 1 is to 0. We did those 0 degrees, 90, 180, 270, and 360. Check that video, it's available there. It teaches us, it shows us how we get all these things together. We've got the ratios, for pi over 6. I wanted to, as I said, to give you the whole perspective so that you can see 30 degrees is also equal to root 3 over, 30 degrees is also equal to pi over 6 in radians, and the x and y values, the x value is root 3 over 2 and the y value is a half. We also put it then, I also put it then in decimal form. Root 3 over 2 is 0.866 and half is 0.5. That's a decimal form. Right round, we go right round. Pi over 4 is root 2 over 2. The x value and the y value is also root 2 over 2. I just gave these colors so that it shows clarity that the x values are the blue ones. All these blue ones here are their x values, and the green ones are the y values. Remember, we said x is equal to cos theta and y is equal to sine theta, right? So all these green ones represent the sine theta, and all these blue ones, they represent cos theta. In other words, this is it here. Maybe I should have used black so that my explanation is clear. So this, if the angle is here, this would be the y value. This would be the y value, which is y is equal to sine theta, and here should be the x value. X equals to cos theta. That's if our angle is here, and this would be our hypotenuse, which r is equal to y. So y value, the y value, all the y values which are written in green here, in green, all the y values coming down here, the y values, the green ones, the green numbers. So all the y values are representative of sine theta, and all the cos values, all the x values represent the cos of that particular angle, all the cos of that particular angle. The red ones, it's pi's, like we've said, we've dealt with it. So r cos theta, x is equal to cos theta and y is equal to sine theta. R is equal to 1 unit. We made it, and this is the theta. So I just wanted to show you that part and that relevance, that each time we are looking for a sign of any angle here, we are looking for that sign, we therefore pick the y value, this value, this value, this value, this value, this value, this value, this, all the green ones, all the y values, because this side it's y and this side it's x. And this side it is x, but I had put it here. This is the x value, this is the y value, this is the x value, the y value. Why did I put 2 here? Just to show you the ratios, and but also to show you that where x is 1, even on decimal form it will remain 1. Where x is 0 on decimal form, it will remain 0. But on root 3 over 2, the decimal form is 0.868. On half, the decimal form is 0.5. That's what I was showing you here. So that is what I wanted to show you. I put it all together like this to give you that, so that you can see what is all that is happening here. For instance, if we are given sine of 30 degrees plus cos 225 degrees plus, let me put tangent of 240 degrees. Right, we come back to our table here. We know sine of 30, we go to 30 degrees, and we know sine is y, we take the y value. So sine of 30 is, if we are dealing with it in the ratio form, not in the decimal form, it would be half, plus cos 225, cos of 225, we're looking for the x value. Of course, here it was sine, we were looking for the y value, and cos we're looking for the x value, which is, maybe let me do this just for interest's sake. Just for interest's sake, let me say sine 30 degrees, just to give you, so this would be half here. And the cos, since I used blue on cos, let me, cos 225 would be a negative. Here, cos 225 negative root 2 over 2, because we're taking the x value here. And here, we took the y value. You see? It's the y value, it's the x value. On tangent, let me say, just to give it, tan to, did I say tan to 40 degrees, which would be plus tan is opposite over the adjacent, O over A, opposite over the adjacent, and our opposite is y. Remember we had this, and the angle here, right angle here, and this is y, is our opposite the angle, and x is our adjacent the angle. So opposites over y, we say, then we say tan 240 would be equal to sine, which is y, sine 240 degrees, all over the cos of 240 degrees, cos 240 degrees. And this gives us the sine of 240 degrees, the sine of 240 degrees. Here is 240 degrees, it's the y value. It is minus root 3 over 2 all over the cos of 240 degrees is a minus a half, Right, so we have this, we've got this, we've got this. So we say half plus, maybe I should change this to black, plus oh, it cannot be plus because it's positive. Positive times negative, it's negative root 2 over 2. And then here it is sine 240, tangent 240. The values are negative, they both negative here. So let's put a plus here. And then we work this out first. We say root 3 minus root 3 over 2 multiplied by minus 2 over 1, where this will cancel and negative cancel. Let me put this here, and then we've got root 3 here, root 3. So it's root 3 plus root 2 over 2 minus a half. And then from here we work out our calculations. I don't want to wipe this now because I haven't finished with it. 1 over root 2 over 1, this would be an over 1. And then we use arithmetic to deal with this. Because of space, I'll leave it here, but you can work it out. Find the common denominator, which is 2. 2 into 2 goes 1 times 1, it's 1, minus 2, it's root 2 and root 3, and then you can work it out. Because of space, because I don't want to wipe this which is above, because I still want to explain few things, but I'll leave it here. Maybe let me leave it for you to finish it. I'll leave it here. So this is how I'm just trying to show you, using this you can come to this and get the answer. Right. So yes, ladies and gentlemen, this is what it comes up to. And the decimal form of these things, the decimal form here I didn't put. The decimal form here, it's 0.5 root 3, it's a negative 0.5. I need to remember that, negative 0.5, and here it's negative as well, negative 0.866. It's a decimal form of this one. Oh yes, this is this, this is this, this is this, this is this. It's a decimal form of this one. Negative half into negative root 3 over 2, it's negative 0.5 to negative 0.866. That's the decimal form. So we dealt with degrees, with radians, and then with angles. Dealing with angles as well. We'll do exercises that involve degrees, involve radians, and then the just finished one, just did one example where we deal with ratios, because that's how we deal with this whole thing. I hope it's clear to you, and I hope you can work it out. The ratios, we've explained ratios when we dealt with 30 degrees, we explained ratios, 45 degrees, it's explained there, 60 degrees, and all the others we did. I just wanted to put it up here all together to see how it all plays along each other, how it all relates. So this is what it is. And then I put cast. We also have a video that explains cast. What is cast, why cast, and all that. It's here. Cast is for cos here at the fourth quadrant. It's cos. What does it mean, cos? Cos is the positive ratio, is the positive x, because cos is the x value. So the x value is positive here, the y value is negative. So looking for positive ones, cos is positive in the, or rather x is positive in the fourth quadrant and also in the first quadrant. That's where cos is positive. If you look at this here, the x value, cos is the x value. The x value is positive here, positive, 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 positive. in this quadrant, it is positive, including this 240, because 0 is also positive. We don't have a negative 0, we just have 0. But x values that we're concerned with, x values are positive, all positive in the fourth quadrant, and x is equal to cos of theta. Therefore, cos is positive in the fourth quadrant. In the first quadrant, all of them are positive. The x value and the y value, they are both positive. Why? Because the y value is this line here, y value is positive, and the x value here is positive. So they are both positive. Here, the y value is negative, as you can see, negative, 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 negative. But the x value, this side, is positive, making cos positive in the third quadrant and positive in the first quadrant, because they are all positive in the first quadrant. In the second quadrant, it is sine. We said y is equal to, a sine of theta. Y is equal to sine theta. So sine is positive in the second quadrant. Why? Because all the y values are positive, positive, positive. All the y values in the second quadrant are positive. The x values in the second quadrant are negative. Why? Because y in this quadrant is positive. Here, y is positive, this side. All the y values are positive, and all the x values are negative. So the x values are negative, and the y values are positive. This one is negative. So hence, sine theta is positive in the second quadrant. The second quadrant and the first quadrant. So which means sine is negative in the third and the fourth. It's only positive in the second and the first. Why in the first quadrant? Because all of them, all cos, sine, tangent are positive in the first quadrant. So if I say tan 45 degrees, it will come out positive, because tan is sine 45 degrees over cos 45 degrees. And sine 45 is positive, and sine 45 is root 2 over 2, and cos is root 2 over 2. We bring it here, we say root 2 over 2 multiplied by 2 over root 2, it cancels, and therefore tan 45 is equal to 1, which is positive. It's a positive one, because we were dealing with angles in the first quadrant, and both these angles, on all these angles in the first quadrant, 90 degrees to 0 or 0 to 90 degrees, it's positive. All these are positive. Cos is positive here, sine is positive in the first quadrant. And then tangent, because tangent is made of, so we say tangent is made of theta, is made of sine theta over cos theta. Therefore, tangent in the third quadrant will be positive, because sine will be negative and cos will be negative. Let's take, for instance, tan 210. Let's say tan 210. Let me put 210 here, and 210 sine 210 degrees, 210 degrees. And both negative sine 210. Let me just put sine 210. Sine 210, the sine value is a negative half, all over the x value, which is cos, would be negative root 3 over 2. So already the answer is going to be positive, because this is negative and negative, and then we work out half multiplied by 2 over root 3, it cancels, and the answer is 1 over root 3. 1 over root 3. It's 1 over root 3. In decimal form, 1 over root 3 would be 0.577, if I'm not mistaken. I do believe it's 0.577 in a decimal form. So this is how it would be, because it's tan 210, and it's here in the third quadrant. It's sine 210 over cos 210, and then we work it out, we get a positive 1 over root 3. Why? Because the tangent is positive in the third quadrant. I think I've explained all of them. Third quadrant and the first quadrant, tangent is positive. Fourth quadrant and first quadrant, cos is positive. Second quadrant and first quadrant, sine is positive. So this is what I wanted to show you guys. This is what I wanted you to see. I've put it all here. Hope you get it right, and you do it, you use it, because you will need it. If you are in mathematics, high school, tertiary, you will need this. You will need this. You will need this if you're doing mathematics. This is what is important. You need it in trigonometry. Without these, it's kind of difficult to go with your trigonometry. I know many use calculator, yeah, which is okay. It's not a crime, but at times you are hindered to use a calculator. They specifically write there in a question, heading of the question, say, without using the calculator, find sine 330, find cos 60, find tangent 270 or tangent 210, or whatever figure they give you. It becomes difficult if you are not clued up with these things, and they don't want you to come into the paper with these values. They've got to be in your head. So it's important you know this, and keep repeating it, learn it, know it. It will help you. Right, guys, thank you for watching me, and with that I want to say God bless you. The 360 is equal to 2t. I didn't write here 1 is to 0 because it's the same. 0 degrees and 360 degrees, they share the same platform, they share the same line, so it's 1 unit in the x-axis and 0 in the y-axis. So x is 1, 0, they both share this, hence you see me leaving it like this. In the decimal form, 1 is 1, 0 is 0. There is no point what if you want to get 1, 1 is 1. If you want to get 0, 0 is 0 in the decimal form. So yeah, hope you got it right. Hope you're getting it right. Hope you are understanding it. And that is all there is to it. I'm trying to think if I'm missing something. No, I don't think so, because most of these things are explained in other videos. This was just a total layout of the whole thing that we're doing, using the circle, using the unit circle here, just to put everything in proper perspective. What I'll do next is to put all these things in a table form. So we'll have degrees going down, we'll have radians, we'll have the y value, we'll have the point, the decimal point value, and then we do another one with the x value, because y and x, we need to put them differently, because when you're representing them in a graph, when we put them in a graph, they are a bit separate. And it also helps if it's in a tablet, in a table format. You easily take figures and put them in their own places in a graph like this. So this would be 1, this would be 2, and therefore 0.5 would be somewhere here, and 0.7 would be somewhere here, somewhere here. So you'd put a line like this. You'll see when we're doing graphs, and a line like this, and then your root 3 over 2, which is 0.8666, it's below 1, would be somewhere here. And then we have the y1 value. Let me increase my 1 just so that you can, let me put my 1 here, just, or maybe let me leave 1 at the top just so that you can see. So it's 0. Let me put 1 here. Let me put 1. So it's 0.7, it's 0.8, 0.5, 0.7, 0.8 here, and then it's 1, because we've got the value 1 value -1. The same thing below, we do minus 0.7 because we've got minus 0.707. We also have minus 0.8, put it here. We also have below minus 0.8, we've got 0.5 would be here, and then we have our 1 value here. Let me put it like this. This is for 1, and then we use these values here to plot the graph. Either we use degrees here, or we use radians here. Either or, we use any of those, and then we plot our graph from that, depending what graph it is. It's 30. At 30 it goes, at 30 degrees it would go to 0.866 and 0.5. We said this is 0.5 and 0.866, so it will go, this is 0.5 and then it's 0.866, and then that's the y. We're taking, if this is the sine graph, let's say if this is sine theta, right, graph, let me put graph. So we deal with y values. So here it would be 0.5, here it would be at 30, at 45 it would be point, here is 0.7, at 45 would be 0.7, at 60 it would be 0.8, here is 0.88, here is 0.8, at 1 it would be 1 would be, we said 1 would be, 1 would be here, and then we put here 1, and our graph will go like this, and then it comes down to this here, it comes down to this, and then we carry on, it comes down to this, and then our graph would be like this, until it goes right round to do what a sine graph would do, would be like this. So it would go just as mine is stretched because of the figures I've used. I'm doing every other, but it comes to this at the end. Just trying to show you, because you're dealing with the sine graph, which we're focusing on only the y values. So we put the y values right round, y values here. These are the y values, and our y values move from 0. It is 0, it is 0.5, it is 0, it is 0.5, 0.5, it is 0.707, it is 0.866, and then goes right around 0.866, it's 1, and then it comes back again, 0.866, but it's carrying on, 0.866, 0.707, 0.5, it comes back, it reaches 0, and then it goes to the negative. The y value, it goes to the negative. When it gets here at 180, if our 180 was here, which would be here, 180 degrees, it then goes to the negative. As you can see, it's negative, 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 and negative 1, up until we reach here at -1. Then from then, it's still negative, but it's going up in values now. So it starts going up. It's still negative, but it's going up now. Goes up, it goes up, it goes up until it gets here. But you'll see when we're doing graphs, why I'm doing this, why I'm saying this, to show you how it all correlates, how it all puts. If I had a bigger board, it would be clear, because I would leave this like this and we would work from this to explain everything. Even when we get to graphs and see as it follows, we would start here at 0, we come at half, we come at √2/2, which is 0.7/7, 0.866, 1, 0.866, √2, it keeps going, and it guides us as we go to the graph until we fully finish our graph. Same thing with the cost graph. We would focus on the y, on the x values. Same thing with the cost graph. I just want to do something, ouch, something, but you'll see when we're doing it. Hope you'll enjoy it. It's the y graph would be like this. Why? Because it starts at 0. We've got 0 here. Why? It follows by half, carries on right round until it gets to a 0. Like I said here, 360 has the same values, 1 and 0. Those are 360 values. 360 values. That is why it takes us from 0. Here it goes right around the y value from 0, right round, and it takes us back to 0. Hence it takes us back to here where our 0 is. Same thing with the cost graph. Let me at least expand my. Same thing with the cost graph. It will do the same, but the cost graph doesn't start from 0. It starts from 1. So we started here at 1, value 1, and it takes us √3. So we're moving from 1, we're coming down. 0.866 would be somewhere here. This is 1.866 would be somewhere here. It comes down, it comes down. It gets to, once it gets to here, so it gets to minus half, which is 120 degrees. At 120 degrees, so this would be 120 degrees. Remember, at y it was 180 degrees, where it turned 180 degrees. Why 180 degrees? Because that is where it stopped being positive and started being negative. The x value, the y values, they were positive this side, positive this side. Remember, sign is positive in the first and second quadrant. So both first and second quadrant, which total up to 180 degrees, it is positive. But below 180 degrees to 360, it is negative, as you can see. That's the sine graph. You can see at 180, it changes, it becomes negative. It goes on the negative, until it gets to 360 degrees. If you look at these figures here, negative, the y value, negative, until it gets to 0. It stops at 0. The cost graph starts at 1. It goes, but from 1 you can see it goes down. It becomes less, because if you take this line here and move it up to there, it gets lesser and lesser until it gets to 0. As it gets to 0 here, if you look at these figures, √3, 0.866, 0.707, 0.5, so it's going down until it gets to 90 degrees, which is 0. As it gets to here, and at 120 it starts going to the negative. It starts reaching the negative. You can see the x values. At 120 it becomes negative half. At 120 would be here. This would be 90. 90 is at 0. My bad. It's at 0 at 90 degrees. The cost graph, it's at 0 at 90 degrees. You see, 90 degrees, it's 0. So here would be 120 somewhere here. So it starts being to the negative. It's negative half. It goes half. It's 0.7, negative 0.707. It goes down to negative 0.866. It goes down, so it's going like this, and it reaches 0 at 270. This would be our 270. At 270 it doesn't stop. It goes up to the positive half now. Positive 707, positive 0.8, positive 0.707, positive 0.8, and then it comes like this. And at 1, when it gets to 1, it stops. Just as it started at 1, it stops at 1. It stops at 1. So it goes like this. But we will do graphs. You will see this whole thing. I just wanted to put it in perspective to see, so that it becomes clear why it should look like this. Why does it do this? When does it change to be negative? When does it go back to positive? You see. So it's like this, and this is the whole thing. Thank you once more.